Hello, guys, welcome back to the new tutorial. In today's tutorial, we will make this facade in Grasshopper. So let's open up Grasshopper and let's start. I chose a curve to starting point. Draw an arc in Rhino and reference back to a Grasshopper. After that, use offset curve from Pufferfish plugin and connect number slider for distance value and its negative value into B input, so we can offset the curve on both sides. By the way, this works for Pufferfish 3.0 and above. If using 2.9 or something, set Boolean to true and connect it into B input. For cap type, set it to 3 so we can get a nice and curvy fill. Extrude in Z direction so we can get surface out of it, and keep it for later use. To tighten this up, I can select these nodes and hit Ctrl-G that make a nice little group. You can also make cluster to keep organized. What we are trying to do next is make hexagonal cells and morph on that surface we created before. Add hexagonal cell node and plug some parameter for X and Y extent. You can also use lunchbox hexagonal cells component, but you need an additional process to remove some fragments. Now I can morph this grid to the surface that we created before. Plug cells out of hexagonal cell to surface morph geometry. For reference box, we can make box out of the cell's boundary. Add bounding rectangle node and connect to the cells. We make sure the bounding box must not be covered the last cells, so it can fit perfectly when it loop. So we need to separate the consecutive branches. This can be done by simply dispatch node. To change direction of lists, add flip matrix node between them. Make sure we flatten the list. That means we'll find the bounding region for all of list in one. Now we can create reference box by using box rectangle node and connect to reference geometry. We parameterize make the surface domain from 0 to 1 so we can easily control. Connect domain from 0 to 1 to the input U, V, and W. This means morphing on the entire surface. You can try by changing the domains. If you set the domain 0 to 0.5, the cells will morph to half of the surface and so on. The gap here is not supposed to be here. It's caused by non-uniform UV. Once I rebuild the surface, it's gonna be okay. Rebuild surface node from lunchbox. Set 3 for U and V degree and set a large number for U and V grid. There is another space gap here, this case from the seam, so we slide the seams to different positions that have a better flat surface. I use adjust seam from Pufferfish tab. With the numbers slider, I can control the position of the seam. We parameterize to make the curve domain from 0 to 1. Next, add some parameters that control the offset of each cell, so we can make geometry out of them easily. One method you can do is offset the original surface then morph cells onto it. So I offset 3 times. I explain later why I chose 3 times. To offset the surface in 3 times, merge 3 number sliders and connect them to offset distance. One thing here, I use an addition node here to make the third value always dependent on the second one. This will help keep the sequence from getting messed up. Here we're going ahead to make a slight inclination for outer cells. To do that, I can rotate the cell in one of their edges by help of rotate axis node. Use list item with -1 as an index. This will help us to get the all items in the last branch of the cells. Flip matrix to change the direction of lists. To get the rotational axis, I can choose one edge from cells. This can be done by exploding the cells and getting one of the edges. There are 2 vertical edges here, the index number 1 and 4, so we can use one of them depending on the index we provided. I can use stream filter to switch between them. In other words, we are changing rotational axis. Now I can combine these cells with the previous one. To keep from overlapping, I use call index and merge together. Mesh Loft from Chromodoris plugin. You can use native Grasshopper Loft component, but mesh operation is a bit faster than NURBS one. Let's give some thickness by offset mesh component from Pufferfish. Add expression minds X to change offset direction. Now let's bake and see what we came up with this far. Now we are going ahead to add these triangular covers. This can be done by extruding the edges to the center. Next, I'm gonna find an average place of the first, third, fourth, and fifth vertices. This gives me the point that is a little bit below the center of the cells. In Grasshopper, list counts start from 0, so the first list has index of 0. Next, find the normal direction relative to the third surface. Then I can move into that direction. To do that, I use the combination of surface closest point and evaluate surface. From surface closest point, I can get the closest point to the surface and its coordination, or UV. Then with this, I can find a normal direction by evaluate surface node. Using this normal direction, I can easily move them in normal direction. Use amplitude or multiplication to change the magnitude of the vector, and finally use extrude point node. This gap's caused because of some mesh faces are flipped, so use Unify Mesh node to fix it. Next we add these strips. The goal is to make a triangle that covered the desired portion. From that triangle, we can make lines between the two edges of it. After that, we can use a pipe to make the strips. Here flip the last branch with its item. This makes 2 points in one branch. By using polyline nodes, we can easily make lines between them. Now the curve is crossing over. To fix this, we can flip curve direction into one of the edge. There is one problem. When we divide the curve, the last 2 points are in the same place, so this will create an invalid polyline. To fix these, we can remove the 2 points by using the col index component. Thank you for watching. See you in the next video.